Okay, before we proceed with the calculation to calculate the average functionality, first we will go through some theory of the gelation. Tri or multifunctional monomer in step growth polymerization will result in branch or cross-linked polymer. Okay, so the molecule growth is not restricted to two direction, and the products are much more complex, and it leads to the further growth of the polymer, which is if we do not control the molecular weight, it can lead to a gelation, which the formation of the infinitely large polymer network in the reaction mixture. We can define that gel as a molecule of essentially infinite molecular weight extending throughout the reaction mass. So in other words, gelation means that the polymer is become extent of the cross-linking. Okay, it tends to become hardened or it tends to become solidified. So the network step polymerization, which is theory of gelation, state that if monomer containing a functionality greater than 2 are used in step polymerization, we can always produce a branching polymer. So if the reaction is carried to a high enough conversion, the gelation is occurred. And the onset of gelation, or we call it as a gel point, is accompanied by a sudden increase in the viscosity, such that the polymer undergoes an almost instantaneous change from a liquid to a gel. And gel point is a true network polymer and the cross-link density will increase. This is the definition of gel point. The sudden onset of gelation marks the division of the mixture into two parts, which are gel and sol. What is gel? Gel is actually the insoluble in all solvent at elevated temperature under condition where polymer degradation does not occur. Okay, so means that it will become a two-layer if you use a solvent, or either it will dissolve in that solvent. But actually, it not well dissolved because the gelation will become what we call insoluble or two-layer, either at the bottom or at the above of the solution, and means that it has a infinite network considered as one molecule. For the sol, it is non-gel portion that remains soluble in the solvent. So as the polymerization and gelation proceed beyond the gel point, the amount of gel will increase at the expense of the sol as more and more polymer chain in the sol are cross-linked to the gel. So as the polymerization proceeds beyond the gel point, the amount of gel increases, okay, at the expense of sol, and the mixture rapidly transforms from a viscous liquid to an elastic material of infinite viscosity. And the gel point can be observed precisely as the time when the polymerizing mixture suddenly loses fluidity, means that it tends to become hardened. And if you carry out a polymerization process, you can see at the flash of the reaction, you can see the formation of the crystal first at the surrounding of the flask, inside the flask itself, before it comes to become hardened. For example, in the preparation of a polyester from a dicarboxylic acid and glycol, where the reaction mixture also contains some glycerol. So hence, the predictions of the gel point conversion is of the great practical importance. You need to measure or you need to control the amount of heat during the reaction. So if the heat used is beyond its limits or out of control, this will enhance the process of gelation, okay, which you should avoid. If that happens, your polymer will tend to degrade, and if the polymer cannot be flow anymore, and it is a degradation point occur or gelation occur. why it is important to predict the gel point. Okay, gel point is means that the polymer is not happen to become hardened. Okay, so we need to predict the gel point because we need to avoid the gelation, especially in a large scale reactor that involve the making of polymer. As the increase in the viscosity, it will make the stirring become impossible. And the characters equation we use to predict the onset of gelation, which is the gel point, that takes into account the average functionality of the monomer involved. Okay, for the network formation, how would you make branch chain that can interconnect to form network? How? So we can use a mixture of bifunctional and monofunctional units. Okay, so please always recall what is bifunctional, what is monofunctional. Okay, for bifunctional means that you have um, two functionality in a monomer. Okay, for monofunctional you have one functionality in a monomer, and you can use a multifunctional monomer, which is it has more than two functionality. Now we look at the example of preparation of polyester um, by using a theory of gelation. Of course, you need to have the equimolar mixture of the functionality. For example, you have a phthalic anhydride structure, trimallytic acid, ethylene glycol, and also glycerol. So the number of functionality, which is the number of functional group in the phthalic anhydride, is 2. Trimallytic acid, you have 3 functionality. Okay, functionality dia tengok kat sini, COOH, COOH, COOH. Untuk yang phthalic anhydride, kat mana kita nak tengok dia punya functionality? Dekat sini, C double bond O. C double bond O represent here. And for ethylene glycol, we look at the functionality at the end of this straight structure, represented by the OH group at the end, both at the end of the structure. For glycerol, we have 3 OH. Right here, we have on the left side and on the right side. And then you need to calculate the average functionality by using the formula FAV equal to F NX times with Fx over Nx. So we considered this equation have equivalent amounts. So just add on the number of functionality. Okay, so 4 is a number of molecule. 1, 2, 3, 4. So you got FAB equal to 2.5. This one is the example of network formation. The hydrogen in the alto and para position to the OH group, which are indicated by the star here, can be reacted with the formaldehyde to form the initially oligomer. So it will react with its own functional group in the structure to become a network formation. Okay, this one is the equation to calculate the extent of reaction. Okay, P sama dengan equation yang tadi. Okay, so you can use the PC. Okay, PC is the critical extent of reaction equal to 2 over FAV. So PC is the critical extent of reaction. Okay. At gel point, degree of polymerization is infinite, always infinite, because the gelation occurs when dP is infinite. And gelation will occur at a reaction conversion of 80%, means that it is almost reach a complete reaction, which is the critical process. So if we have FAV equal to 2.5, PC we can get 20 and we can get 80%. In contrast, for difunctional monomer in 80% conversion leads to a dp equal to 5. Okay, this one is for monofunctional monomer lah. So we have example 1 and 2 have equivalent amount of acid and alcohol functional group. Yang ni 3 mole of 1, 2 mole of 4. So 3 times 2 plus 2 times 3 over 5. So PC substitute dia. Memang dia punya equation lah. 2 over FAV. Okay. So given a collection of polymer chain, how many random cross-link needs to be introduced before a network will be formed? So assumption, there are 3 assumptions that we use. All chain have the same degree of polymerization. All monomer are equally likely to react, and the extent of reaction can be measured. Okay, now if you look at the equation, it is a bit confusing because you don't know which equation gonna be used. So by referring to this equation, it might help you to give an overview about the equation that I have shown earlier. Okay, for example, calculate and discuss the total gelation of the following alkyl recipe. You have 1.2 mole of pentatritol, 0.5 mole of maleic anhydride, and 0.5 mole of tricarboxylic acid. Now, what you need to do, you have to figure out what is the functional group of this structure, maleic anhydride structure, and tricarboxylic acid structure. First thing first, you need to draw the structure of pentatritol. It gives you a straight structure like this, right? So it is difficult for you to figure out the functional group. So awak lukis je balik, okay, the diagram. CH2, and it contains 4 OH group, means that it has 4 functionality. So just make this table properly. Name of the compound, number of mole, functional group, and equivalence number. And number of mole is given 1.2. Functional group, it has 4 functionality, which is yang saya dah bulat-bulatkan ni, 4. 0.5 ni adalah markah, markah. And the equivalence means that you times 1.2 with 4. You got 4.8. Okay. And for the other structure, maleic anhydride, number of mole is given by 0.5. Functional group dia berapa? Ada 2 kan? CO ni, awak tengok yang dalam kurungan ni tau. CO ni ada 2. Bukan yang tengok yang C6H4 ni. Yang ni kita tengok dekat OH, bukan CH2. Dekat functional group sahaja. And untuk tricarboxylic acid, COOH, COOH. Bukan CH2. Bukan CH2 yang ini. Okay, so awak kena darabkan 0.5 with 2. And then you have to sum up all the number. Okay, tambahkan equivalent number dia. And also don't forget to add the number of mole. Tambahkan semua number of mole. So first thing you need to measure the FAV value by using the equation FAV equal to NX times with Fx over NX. So NX kita dah darabkan dah ni. NX time dengan Fx. Dapat dah 4.8 kan. Cuma dia nak total number. You dah buat siap-siap kat sini. So you got 6.8. 6.8 divided by number of mole, which is 2.2. You got 3.09. Okay, how many mark? How many mark? You have got 1, 2, 3, 4, 5 mark already. And the second one, calculate the extent of reaction, which is PC equal to 2 over FAV. Just substitute the number of FAV given or you got in the first calculation. You got 3.09. So times with 100% because we always want the number in the answer in the percentage. Okay, don't forget to conclude